Hello everyone and welcome to today's SPaT Challenge webinar, Design Consideration, Part 3. My name is Nilu Parvinashtiani and I will help facilitate today's webinar. Today's webinar is hosted by the National Operations Center of Excellence, NOCO. At NOCO, we offer resources to support the transportation systems management and operations community. If you look at your screen, on the bottom left side of your screen, you can see the useful links box where several links are shared with you. The first one is NOCO's Knowledge Center. So in NOCO's Knowledge Center, you can browse through an entire collection of TISMO resources. Also, another link that is shared for you is the Register Subscribe. That is for subscribing to our website and also our bi-weekly newsletters for major TISMO announcements. You can directly download today's slides as well as the previous SPaT Challenge slides here through the Download Slides or Resources box on your screen. You will be able to do this now and also at the end during Q&A. So let's go to the next slide to cover a few logistics. So for this webinar and every webinar, we will be recording the webinar, and that would be shared with you along with the presentation slides through our on-demand learning section of the NOCO website. This is usually available 1 to 2 days, but NOCO website is undergoing some maintenance and refresh, so I expect this to be available sometimes early next week. We will have a question and answer session at the end of the webinar, so please use the question or discussion pod that you can see here on your screen to ask any questions that you have anytime during the webinar. These questions will be read out loud at the end and our presenters will ask each question. To clarify your question, and if possible, please direct your question to a specific presenter. You can also ask a question for the whole panel. So next slide. Here we have our agenda today and our presenters. For accessing presenters' full bios, please use NOCO's website to learn more about our speakers today. So today we'll have Blaine Leonard from Utah DOT who will go over an introduction in the beginning. Next, we will have Ed Lisley from Leidos to cover the RSU specification version 4.1. Deb Curtis from US DOT will also be available to support Q&A for this part at the end. Our next presenter is Raj Panolori from Florida DOT and Brian Reed from WSP, who will cover roadside equipment and backhaul communications. The final speaker today is Yang Tao from City of Madison, who will talk about the SRC licensing. After all the presenters present, we will have the Q&A session where all the panelists help answer your questions. So that is all I had, and with that, I'd like to turn it over to Blaine to start us off with the webinar.
Thank you, Nilo, and I'll add my welcome to everyone who is joining us today in this webinar. It looks like right now we've got about 120 people who've connected with us to participate in the webinar today, so we appreciate all of you doing that. We hope that you'll have some tangible takeaways from the webinar today. So as usual, we start out with just a little overview of how we got where we got. I'm sure most of you, if not all of you, are familiar with the SPaT Challenge. It's a challenge we've issued to each other who are owners and operators of infrastructure to deploy DSRC and broadcast SPaT and MAP in every state by 2020. And you can see on the map, which you can get to on the NOCO website, that at present We have about 35 locations in 25 states. So we're sort of halfway there in a way, and we're about halfway there in time. The SPaT Challenge was initiated 2 years ago last month, and so we're a couple of years old. We've made a lot of progress here, and we're really excited about the momentum that's going on. These existing deployments contain about 500 RSUs operating around the country in various places, and the ones that are planned will add maybe 4 to 5 times that many more from what we can tell from the information that all of you have provided to us. So we're excited, and we're continuing to move forward, and we encourage all of you, if you're not on the map, to get on the map, and to encourage your neighbors, those are your colleagues in other states who haven't deployed yet, to start down that path. So this is a series of 6 webinars on the SPaT Challenge, and we've done 4 to date, and as Nilo said, the recordings are available for these webinars, and you can also download the PowerPoint presentations from these webinars in one of the pods on the screen today. The first webinar started back on March 6th, and it was sort of an introduction to the SPaT Challenge. We talked about systems engineering and concept of operations, a little bit about how to select a corridor and what kind of costs you may be into. And then we moved into some design considerations. On March 20th, we talked about the SPaT message and how you get it. We had an introduction to the V2I Hub, which is a US DOT product. We also talked a little bit about deploying onboard units, even though that's not directly part of the SPaT Challenge. Many of us are taking it a next step and putting some units on board some vehicles. The second design considerations webinar on April 17th focused on the map message, and we talked a little bit about position correction, or RTCM, and when that might be needed, as well as that enhances the GPS signal. And then on the 24th of April, we had a detailed demonstration of a map creator tool, which the US DOT has developed. So here is the SPaT Challenge website on the National Operations Center of Excellence web portal, and you can see here the blue arrows tell you, the green arrows tell you where you can register for these and get recordings for the past ones. If you are working on the SPaT Challenge or have clients that are, or neighbors that are, this is where they can tell us what they're doing. We'd love to get everybody on the map, give you credit for the good work you're doing, and encourage others to do so. I know there's some deployments out there that aren't on the map yet. We need to get them up there. And here's the general resource page that includes the documents that our resource team has produced so far, and indicates a couple that we're still working on and trying to get up. So hopefully that's a good resource for you. You can find good information there. We have after today, we have one more SPaT Challenge webinar in our series, and it'll be on June 12th. It will focus on validation of our deployments, a little bit more about procurement and verification of the messages being sent, and we'll talk some about security, the security credential management system. And so this will be a good conclusion in that it talks about how once we get up and operating and deploying, sending our messages, how we validate that they're actually receivable in the format we intend them to be. So that's sort of the overview, and that's kind of how we got where we are. We again welcome all of you to today's webinar, and with that, I think I will turn it over to Ed Leslie and Deb Curtis to talk about the roadside unit specification version 4.1. Ed.
Hello, this is Ed Leslie. I'm with Leidos, and our group was tasked by Deb for the past couple of years to develop and update the 4.0 and then 4.1 version of the RSU specification. So I'll kind of give an overview of an RSU and the 4.1 spec in particular, and then just go over a few points where we've gotten a lot of feedback or questions about parts of the spec. So just to get started, so I'm not sure what everyone's baseline is, so I'll just run through key points of what an RSU is. This is kind of the interface between infrastructure and vehicles. So it provides data about an intersection, signal phase and timing, or or a map message to describe the layout of the intersection, and it also provides information about any incidents or maybe a tight curve that's coming up ahead on the road in the form of a TIM, a traveler information message, or maybe roadside alert, or basic infrastructure or information message that may be rolled into the spec coming up soon. The RSU is also able to collect information about vehicles that are passing it through the basic safety message or probe vehicle data that those vehicles are transmitting. The data that an RSU sends is used or received by an onboard unit on a vehicle, and the vehicle uses those messages to inform maybe an automated vehicle algorithm of how it can alter its trajectory through a traffic signal, or whether there's an incident ahead that needs to be prepared for. There are also a couple of other messages and functions that an RSU provides. So an RSU has 2 radios, but it's able to operate on 3 different channels. One of those is a continuous channel that's usually tied to channel 172, sometimes called the safety channel, that vehicles use to transmit their basic safety message. The other radio alternates between 2 other channels, the control channel and the service channel. And in order for a vehicle to know which service channel the RSU is operating on, it uses what's called a Wave Service Advertisement, WSA. That lists out the services that the RSU is providing and on which channel they can be accessed. One other service the RSU can provide is IP connection through IPv6, and that's another feature that would be advertised in a WSA. Just a little more detail about where we went from the 3.0 version to the 4.1 version of the specification. There are two sides of that. One is on the hardware side, and the other is several improvements on the software side. The biggest hardware change was not really a requirement, but I guess the industry was kind of moving in that direction anyway, and that was to add secure storage in the form of a hardware security module. This was a requirement from the Security Credential Management System, and pretty much every vendor implemented that, even though we only included it as a should requirement. On the software side, we added some requirements to use the Simple Network Management Protocol, SNMP, and that's kind of to make it easier to manage the devices and to manage a large number of devices. We added some health and status monitoring requirements to give feedback on device status, message counts, and things like that. And we also increased some of the security requirements to give operators control of password complexity, to close down ports that aren't needed, or just close them by default, let the operator decide which ones need to be opened, to implement a firewall, that kind of thing. And the last big improvement or modification was to require the latest version of the CV specs. So that's the 2016 version of J2735 and the IEEE 1609. Forgetting anything so far, Deb?
Nope, sounds good.
Okay. So I'll just go over a few details about some of those points and about the RSU features in general. So I mentioned we implemented, or we required, an SNMP implementation. So this provides some improvement in security. There's some some improvements built into SNMP version 3 that improve security over traditional, the method that messages were traditionally loaded to devices through SCP or FTP. This simplifies device interaction and also makes it easier to manage a large number of devices. Other hardware that goes into infrastructure is also managed by SNMP, so this is something that a lot of people are familiar with. It's been around for a while. Another big feature of the RSU is message forwarding. So this came up from several sources. So we have the ability to forward messages from a TMC through an RSU to a vehicle, or vice versa, from the air through the RSU and back to the TMC. And there's a lot of layers of information in those messages. And one question that we got a bunch of times, we've got from several parties, was how much of that message needs to be forwarded. So we have the 1609.2 and .3 headers. There's useful information there that might not be useful for everyone. So one solution to that is to make that configurable, which may come out in, I guess, kind of a follow-on specification that'll handle communication between infrastructure and the RSU, like the backhaul communication, NTC IP 1218, that's currently in development. Another question about message forwarding had to do with the WSA. So the WSA broadcasts services that are available on the RSU. If we're using a store and repeat message, that message is programmed into the RSU with a well-defined start and stop time. In the case of immediate forward messages, where a TMC might send a message to an RSU to have it broadcast immediately, there's not really a well-defined start and stop time, so it's a little bit more of an issue to determine how long that message or that service should be advertised in the WSA. And that's another thing where verification in a future release of the spec. Another feature that got added, well, actually was in the 3.0 spec, but kind of got a little more clear, but maybe not clear enough in the 4.0 and 4.1 spec, is RSU set, which is the ability for multiple RSUs to operate as a single unit and appear both to the TMC and to any passing vehicle as a single unit. This simplifies communication in two ways. One is that there's not an excessive amount of traffic on the network going between the RSU and the TMC. And the other is that there's not an excessive amount of traffic on the airwaves between the RSU and the vehicle. So this is one feature that we've noticed has kind of given the vendors a little bit of a challenge, but we think it's one critical, very useful feature that deployers will be able to take advantage of. So part of our tasking with developing this spec was also to develop a functional test plan where we can test functionality of devices from different vendors and provide feedback to them and to early deployers on how those devices handle key areas of the spec. And this is a list of the key areas that we tested from the 4.1 requirement. Physical requirements included weight, LEDs to indicate status of the device, communication ports, ingress protection for waterproofing and dustproofing. For positioning, the devices all have access to GPS. So we want to make sure that that's reasonably accurate. SNMP, we want to make sure that all the objects are implemented, that we have access to the ones that we're supposed to have access to. For logging, we're logging like a system log for the operating system, and then also messages that go in and out of the RSU, either on Ethernet or on the wireless side. Security, make sure that we can program password complexity, make sure that we can set rules for the firewall that aren't violated. For message forwarding, just make sure the RSU is able to forward, immediate forward, or store and repeat messages, or forward messages back from the air to a local PC. And finally, make sure that the WSA contains the correct information for whatever services are being broadcast at the time, and doesn't include information for services that aren't broadcast on the service channel. By the way, the results from some of those test plans may be available soon, and we can provide a link to anybody who wants to, or actually I guess we might be providing the actual documents. Just kind of a preview on what's to come. We kind of expect there to be a 5.0 release that would be available before RSUs go for widespread deployment. This would include lessons learned from early deployers or from SPaT challenge participants. And we don't expect that to be released for maybe several years. I only hit on a few of the points that we've gotten feedback on regarding the spec. We have a lot more in a frequently asked questions document that we plan on making available soon. And any further questions can be asked through the CVCS support site, which we'll show a link on the next slide. But before that, we have the specification and the test plan for the 4.1 spec available in the National Transportation Library at the two links that are shown here. And finally, here's some contact information if you would like some more information specifically about the spec. And also there toward the bottom is the website for the CVCS, that's Connected Vehicle Core Services website, where you can submit questions or I believe also request to loan equipment, including RSUs and OBUs. And that's about all I have.
So this is Deb Curtis with USDOT. I did just want to address very quickly the questions that pulled up in the chat box about the latency issues associated with a central message. And I think there might be just a touch of confusion, and what we meant was that you can configure the RSU in terms of how it is going to broadcast using 1218 about how often it's going to broadcast particular messages or how these messages are formatted and those sorts of things. We weren't necessarily saying that 1218 would allow you to broadcast messages from Central, but rather that you can configure the device to be able to change how it is handling store and repeat or immediate forward messages and those kinds of things from Central rather than having to go out to the device in and of itself. And then I see there's one more question that's related to how version updates are being handled and how they can be pushed over the air, and that's also going to be something we're going to be looking at with 1218. And I do want to point out that 1218 is an NTCIP standard, which means it's a communications protocol. It is not a physical device standard. When we go to move from a 4.1 specification to a 5.0 or to an RSU standard from a specification, it will likely not be an NTCIP standard because that's a device specification or device standard and not a communications protocol standard. But 1218 is going to define how we can configure, monitor, and log data from these roadside units from a central location rather than having to go out with a flash drive and a bucket truck to be able to do so. So pushing over-the-air updates is something that we will be looking at in 1218 because that's part of configuring the devices, part of maintaining your devices. And as far as it being vendor-specific, there may be elements of it within the payload that would be very specific, but the format to how to push information out to the devices for an update is something that we're considering in the 1218 standard. Again, that is an NTCIP standard, so the working groups are open to anyone interested to participate.
Thank you, Deb. Thank you, Ed. That was a good presentation. So next we have Raj from Florida DOT to present us with roadside equipment and backhaul communications. Raj?
Thank you, Neelu. Thank you all for the opportunity to present on the Florida DOT's signal phase and timing deployment, the first one that just got completed and was operationalized, and that is what we would like to present today. But before we do that, I just want to give you all a quick overview of where we are with how this project has begun and what all we have done to get here. Neelu, I want to go to the next slide. Neelu, can you advance the slide?
Yes, that is also available through the red, the right arrows that you see on the screen, just so you know. Okay.
So yes, as we just mentioned, we're going to go ahead and talk about the agenda. The goal is to present to you very quickly what is AASHTO SPaT Challenge. Most of you probably are very familiar with it anyway, but we'll just touch on it real quick. We would like to explain to you what the Tallahassee SPaT project has been all about, and the various technologies that have been deployed, some of the testing that has taken place here, and the deployment considerations. The Tallahassee SPaT project, or the project that was implemented recently, is a part of the Florida DOT's Connected and Automated Vehicle Initiative. And what you see in front of you on this slide is a snapshot, or Table 5, from our TSM&O, Transportation System Management and Operations, TSM&O strategic plan that was adopted as of August of 2017. We have identified 6 primary focus areas, and one of the focus areas happens to be connected vehicles. And the whole point behind this is to indicate that connected vehicles is not necessarily a standalone effort. It is not a silo effect as much as it builds on several other efforts that have already taken place, including a very strong ITS, Intelligent Transportation System program in the state of Florida. It builds on the ITS cost feasible plan. And last but not the least, it is consistent with Florida DOT's 2017 TSM&O strategic plan, which we are beginning to implement in the state. This is also in line with the statewide arterial management program, or STAMP as we call it in Florida. We just completed the 2018 STAMP action plan, or the first action plan of its type, and you will notice on this particular slide that we put a lot of emphasis on outcomes and performance assessment. And to accomplish the outcomes and performance assessment, we do want to get into traffic control strategies. We want to get into field technology deployments, traffic management center technologies, operations and maintenance. And in that green box, you will notice that there's a significant amount of emphasis on traffic signal technologies or adaptive signal control technologies, connected vehicles, freight signal priority, etc., connected vehicle traffic signal systems, transit signal priority, bicycle pedestrian safety, etc. And the reason why we put such an emphasis on the connected vehicle program in Florida is because of two specific objectives, safety and mobility. We know that it is easy to say, let us do safety and mobility through connected vehicles, but at least in the state of Florida, our goal is to embrace emerging technologies as a way to make a dent in the safety concerns that we have. For example, bicycle pedestrian safety is a major cause for concern in the state of Florida and elsewhere in the country as well. We do believe that technologies such as passive pedestrian detection can play a significant role in this. So the slide that you see in front of you is the Florida DOT's Connected Vehicle Initiative. We identify 16 specific projects or initiatives that are underway in the state, and you will see in the green number one, that is the Tallahassee or US 90 project, which I'm going to go into some detail now. As we speak, we have a second SPaT project which is on the street. We have issued a request for proposal for the Gainesville project, which is at the University of Florida campus, and that project is advertised, and we are waiting to select a vendor, which should be completed in the month of July. And as I mentioned at the outset, most of us are familiar with AASHTO's SPaT challenge. I'm not going to go into details, except to say that the challenge calls for 20 signalized intersections with SPaT information or SPaT deployment with 20 intersections per state in the 50 states by the year 2020. That totals 1,000 intersections by 2020. Here is the Tallahassee SPaT project. It extends from Duval in downtown Tallahassee up to I-10. It is a total of 21 intersections on what is called Tennessee and Mahan Drive, pretty much from downtown Tallahassee up to I-10 or Interstate 10. The key note about this project is that this is being done in close partnership with the city of Tallahassee, and we greatly appreciate their support. In fact, my supervisor, Mr. Fred Heary, is instrumental in conceptualizing this project, and we do believe that this project has really been a game changer for us. It is a small but a very significant part of the Florida DOT's Connected Vehicle Initiative. I'll go into details on the project, but in general, we completed the vendor selection in the October-November timeframe of 2017, and we just completed the deployment of the roadside units. We obtained 4 roadside units, 4 onboard units, and 2 multi-channel test tools. Integration has been a significant component of this project as we look back, and I'll try to touch on some of those elements. So when we get questions from other states on what kind of questions should be asked prior to installation and deployment, we always suggest that it is important to ask if there's anything that needs to be installed physically or hardware and of course software to the existing infrastructure. The answer is very obvious, and the answer is yes. But the question is, what infrastructure are we really talking about? It is important for any new deployer to know exactly what is being deployed and what is being installed, whether controller space is adequate or not. In the interest of time, I'll move quickly and always ask us questions. We also need to know how the controller will be communicating to the roadside unit, whether the roadside unit should be placed on the vertical of a mast arm, or whether it should be on the placed along with the antenna itself at the middle of the intersection on the horizontal portion of the mast arm. So questions of that type are simple but very important. And here's the key: map data files. At the end of the day, even though we call it a SPaT project, map is a significant and the main ingredient of any SPaT project. So understanding as much information as you can about map data is also the key. And that means what kind of map data are being collected, where will the map reside, etc. These are questions that should be considered. This is a pretty straightforward slide, but the reason why it is here is just to show that most of the controller cabinets are pretty busy. They have very little space. So it is always important to ask the question on what kind of infrastructure or what kind of equipment would be brought to this to the table when you do your roadside unit when you do your SPaT deployment. And that means we all need to ensure that the traffic controller, both firmware and the space, would be adequate enough to deploy a sustainable system and a good system. From a roadside unit standpoint, there is definitely a lot of configuration that needs to happen before the installation. I have to say that when we say integration or when we talk about integration, this is the kind of detail one needs to be completely aware of. The MAC IDs, the IP addresses, and any unique attributes. So technical skill set is absolutely important, and it is always helpful if the local agency or your partner is actually keenly aware of the technical details, including the IP configuration, and therefore the network details really become important. Here in Tallahassee, at several intersections, we needed more than one roadside unit. Even though the roadside units are omnidirectional, in other words, they can look in all directions, 360 degrees around, they are line of sight constrained. So if you happen to have landscaping or the roadway geometry, which is going to affect the directionality from the roadside unit to the oncoming vehicles or vice versa, obviously we may need to have more than one roadside unit. So in Tallahassee, at the 21 intersections, we deployed 34 roadside units. So you can see that at several locations we had more than one, obviously 2 roadside units. And therefore a good comprehensive field review before or during the planning stage is a very important element of the project. Let's see. Just one other quick point, some basic details which every traffic engineer is keenly aware of, ensuring that all the devices are properly secured and they're in a watertight compartment type of detail is essential. Just a few pictures of some installation we did during the pre-deployment testing at our Traffic Engineering Research Lab. That is what TERL stands for, Traffic Engineering Research Lab here in Tallahassee. TERL is responsible for evaluation of all the equipment that goes onto the public roadways and becomes a part of the approved product list or APL. Here are the roadside units that are deployed in the field. You can see that the roadside unit along with the antenna is actually deployed on the horizontal or the mast arm to the extent possible in the middle of the roadway so that it can get the maximum visibility in both directions. Here are the antennas that are mounted on the vehicle which receive the information from the roadside units. So that's what the pictures show. Multi-channel test tool is a very important element to understand. A multi-channel test tool is typically used to verify the signal strength and the quality, and also to make sure that the data that is displayed, that is to be displayed, is in fact received from the roadside units. Multi-channel test tools can be DSRC radios that are reserved specifically for use and configured, of course, to detect the roadside unit messages, either with a laptop or another device. And as I mentioned earlier, it is important to understand how to use the roadside units, onboard units, particularly the onboard units and multi-channel test tools, particularly from a MAC and IP address standpoint. In fact, all it takes is one digit to be off and we are not going to receive the data. So quality assurance is an important part of the equation. Onboard units, in our particular case, Android tabs were the onboard units for the display purpose. However, I'll explain to you in a couple of slides down the road on what an onboard unit looks like. The onboard unit configuration varies. Some manufacturer OBUs do not require an external computer. Obviously, we need to ensure that the OBUs can process. This is an important point, the second bullet. We need to ensure that onboard units can, in fact, process and handle the avalanche of messages that come from the roadside units in the field. It could be overwhelming, at times, and that is the reason why a good integrator would understand the fine-tuning elements at the field level. I mean, it sounds much simpler, but once we get to the field, one can understand the gravity of the situation. Obviously, it is important to designate and configure the units before any installation takes place, and that's where the testing is an important element. These are pictures we took from our deployment. Onboard units, as I mentioned earlier, can comprise a dedicated short-range communication radio and GPS that is in turn connected to a Raspberry Pi, and it also includes a cellular modem. It's a Netgear that we had, and a router with Wi-Fi that is in turn connected to a tablet. So that is how our vendor had actually custom built the Roads onboard unit for our use. We purchased 4 Roads onboard units as a part of this project. In an ideal world, it would be nice to have as many as we possibly can. This is a picture from a pre-deployment testing. You can see the green time. There's 3 seconds left here in this particular case. For the left turn, there's 12 seconds left at the other intersection. Here's a small video I'd like to run for you. Maybe not this one, but let's see. These are all, as I said, these are all pictures from the field deployment we had. For some reason, I'm not able to run the video of this particular slide. But anyway, this was supposed to be an 80-second video, it's a 30-second video, which we're not able to run at this stage. But basically, this video would have shown that as you're driving up to the intersection, the actual clock down takes place, and then once the yellow turns on, then you'll be able to see the display as well. There's obviously the messages, the SPaT data keeps rolling in, one would be able to see it during the field testing and deployment. Long story short, we have some lessons which we learned from the project. The Federal Communication Commission licensing system is a key. For those who do not know the FCC licensing process, it is on the one hand pretty straightforward, but on the other hand, it is important to know what it is all about. First, there is a blanket approval for the use of DSRC, and then after you select your vendor, that is when we need to provide to the FCC a comprehensive list of the exact location, including the GPS coordinates, the mounting height of the devices, the make and model of the roadside units and onboard units, and get that second approval before we can actually operate the system at the field level. We need to ensure that the devices are in fact licensed by FCC for use on the project, so the devices should be FCC certified. The proposers should ask questions during the procurement process regarding device compatibility with controllers. I mean, this is probably easier said than done, whether your MIBs are capable of being provided or not. So the controller elements need to be carefully considered when the project is being designed. Map data, as I mentioned earlier, ensure that the map data are properly coded and the UPR hex code is in fact validated for field testing. And we have done that before we put the RFP on the street, so we learned quite a bit about the complexities and challenges of map data. Regardless, even during the deployment phase, there is going to be an opportunity to, there is going to be a need, I should say, to actually make modifications to the map data at the field level. So it is important that whoever the vendor is or the service provider, they need to understand how the map data in fact work. We are planning on expanding our SPaT project and or on other projects, the deployment of other connected vehicle technologies, including bicycle pedestrian safety. With that, I'll end my presentation. That is the contact detail. Do not hesitate to reach out to us either directly or through NOCO. Nilu, I'll turn it over to you now.
Thank you, Raj. I'm gonna ask you for a link for that video, if possible, to share it later on the website so everybody can see it. So thanks for that. We will have Brian Reed from WSP now to talk about roadside units now. Brian?
Lou, thank you so much. Thank you, everyone, for joining our webinar today. Greatly appreciated. So we're going to kind of cover a little bit more detail, at least introductory-wise, on the FCC licensing piece, a little bit on site selection, procurement, some of the cabinet and audit installations prior to going through and doing deployments, a little bit more on management and monitoring, as well as some O&M recommendations in this particular section, and then talk some more about backhaul communications and sort of the secondary breakout portion of the presentation. So just in terms of licensing for the RSUs, just to kind of make sure everybody's on the same page, FCC is definitely the governing agency. A number of the initial pilots are using, as Raj mentioned, that blanket use FCC agreement as part of the grant to USDOT. Any new sites or new deployments, you definitely need to request sort of those site-specific license details for FCC broadcast, and that would include any of the SPaT challenge locations that folks are looking to deploy or set up. So just as a 101, it helps to kind of do site selection, initially gathering GPS locations for potential RSU locations, do the FAA look at each one of those locations, make sure that everything is effectively a no hazard, and then ultimately work through the geographic license, and then once construction is complete and the devices are deployed, to go back through and do the certificate of construction for the FCC Form 601 and push that out for use and ultimately deployment for longer term setups. So we talked a little bit about channelization and effectively how these are broken out or set up for RSU deployments. So most folks at this point are setting up RSUs, and as part of that initial setup implementation by site, you may be looking at certain site-specific applications, as an example, like transit signal priority or signal phase and timing with the map messages, WSA broadcast, and each of those pieces or application sets would be used on specific channels. And so this is just sort of a basic breakout of that spectrum allocation and how folks would set up for those early style deployments for implementation. So some RSU design considerations. So in a number of projects and in different locations, deploying agencies or municipalities may choose to co-locate RSUs with existing communications and ITS equipment. That's totally probably a lower cost implementation method to help kind of consolidate where I've got equipment and how it's being used. That site configuration we'll talk a little bit more about in a moment. It definitely helps to know sort of the standards and specifications and ultimately applications that you're going to deploy as part of a SPaT challenge, sort of early deployment configuration. The USDOT 41A specification, or Release 5 for April of 2017, is a great kind of reference specification to use for procurement when you're looking at bringing in new RSUs to an agency. Mounting height is kind of one of those key aspects of implementation, and so you need to make sure that the maximum height is kind of coupled with the limitation for the antenna power, as well as roughly 26 feet above the roadway surface. As Raj was mentioning, and to kind of can't say this enough, the RSUs do function with clear line of sight. So where you choose to mount those within an intersection becomes sort of a compounding factor to the broadcast distance or coverage area that you might expect to get to equipped vehicles that would have onboard units or OBUs equipped within them. We're generally recommending that the RSUs be effectively a hard fixed mount to basically try to get away from sway or vibration. In a lot of cases, we found that like an 18-inch or 24-inch sort of offset to those strain poles or mast poles is kind of a ideal recommendation for installation. It helps to kind of go out when you're doing that site evaluation and select to look at spectrum analysis and see if there's any existing interference near the band or within the band, and in that way, when you're going through the FCC process, if there is interference within that band, you can bring that to their attention and check to make sure that that license that's broadcasting in that location is valid, or if there's, again, some other regulatory things that need to take place to remove that are done in advance of you deploying the RSUs out there and then not getting the effective coverage that you're really expecting for your specific project. As a detection range for the RSUs, somewhere in that 1,000 to 1,200 meter range, largely depends on antenna tuning or power, as well as site configuration themselves, and that will ultimately help with getting more effective basic safety messages and SPaT safety application messages out to the vehicles to improve how these are performing within project corridors. So this is an example of when you're looking for locations to do deployment. A lot of times we'll be looking at 3D surfaces or a combination of Google Street View and kind of mashing up a couple of different data sets to evaluate where an RSU would be best placed, kind of buffering each one of those areas in a sort of spatial manner to determine how much coverage or overlap might be being seen, and then you can sort of look to that trade-off kind of analysis through that decision-making process to move an RSU to a different location. Certainly if there's an intersection that is a safety critical location that has high accidents or a lot of vulnerable road user usage, those would definitely be what I would call critical drivers to installing an RSU in those site locations. Out along the freeways and those types of things, to kind of broaden out the coverage area, it helps to kind of have those RSUs spread out. And then when you're looking at data aggregation and bringing that back for analysis, it helps you to kind of have a broader implementation for through a corridor or a location set. Getting into some typicals for installations, again, kind of leveraging the strain pole for existing camera locations is a great way to go. Your roadway height, again, affects sort of the positioning of the RSU, as well as antenna placements. Different manufacturers have different implementation strategies for whether the antennas point down or point up. So those are some of the look at documentation and evaluation when you're looking at bid responses to evaluate what kind of site criteria a specific RSU manufacturer will require for installation. When you're looking at sort of a fixed location, a number of times we've found that, again, sort of this D-style connector mounted to the mast pole itself is kind of a good stable position to mount off of. It helps reduce vibration, and with the RSUs looking to get a good 3D or GPS fix, then at that point that helps with making sure that unit kind of operates from a efficiency standpoint. In a number of cases where you're kind of, again, co-locating with existing gantries or your DMS sign structures, you want to sort of make sure that RSU's offset from the structure a bit to improve its performance, as well as get clear line of sight to the traffic that's live in that environment, and making sure that it lines up to the lane sequencing and is able to be deployed in those locations. When you're looking through on the cabinet side, it helps to establish, as Raj was saying, making sure you've got space in the cabinet, that power is set up and ready to kind of be implemented. You've got effectively a spare power outlet to plug in and push to the power over Ethernet injector that a lot of the RSUs are requiring at this point. And again, we're kind of piggybacking on a number of different things at this point, but that the maximum Ethernet distance is roughly 328 feet to drive for both Ethernet and for PoE. In a lot of cases, we'd recommend that for remote sites or even for access purposes, if you've got a device that needs to be power reset, having a remote ability to do that is sort of a best practice recommendation, perhaps. So something like an iBoot would kind of implement or work in that scenario. For the traffic signal controllers, certainly the manufacturer or make, the model itself, and the firmware versions. Certain manufacturers are now sort of enabled to broadcast SPaT directly to an RSU and may not require a secondary piece of hardware sort of in that, I'll call it, broadcast scenario. So that helps from getting that message out to the RSU and reducing potential points of failure within that sort of safety-oriented broadcast for SPaT challenge sites or early deployers. Certainly, looking at the cabinet switch itself, making sure that the backplane supports the additional bandwidth and information load that will wind up happening from sending BSM forwarding from the onboard equipment units through the RSU and out to like a back office data aggregation spot, as well as sending signal phase and timing data from the traffic signal controller through that cabinet switch and out to the RSU. And certainly, one of those key sort of decision points for folks that are looking to early deploy or set up for SPaT challenge is, IP6 implementation, sort of pushing that through the infrastructure or through the sites that are looking to be early deployed versus doing sort of like an IP6, IP4 dual stack, or staying in a pure sort of native IP4 deployment, affect both the equipment, the integration, the configuration themselves of each one of the devices, and to a certain extent, the total life cycle costs for deployment and early implementation. Kind of leveraging off or talking a little bit more about procurement. Certainly, leveraging the 41A, version 5 specification document from the USDOT is a great place to start. When an agency is looking at deploying early or new application sets, adding those pieces and components to the procurement specification is definitely a recommendation. SNMP version 3, in some cases the MIBs themselves are, again, a great place to start, but there may be other enhancements or modifications that might be needed for agency-specific implementation, and those pieces would be best kind of put in place during that procurement and evaluation process. In a lot of cases, as those standards that are in the marketplace are evolving, making sure that any of your standards references that are in the procurement documentation are current is a good recommendation. And then if you're going to go through and do selection criteria or any type of testing pieces prior to doing a procurement, that would definitely be a good element to add in the actual device specification before you release it out. In some cases, we've seen that certain vendors are adding sort of volume discounts. So if as part of your site selection criteria, your total unit quantity, it helps to kind of broadcast that forward in that procurement specification to help kind of drive down the total cost of implementation for deployment locations and any project-specific sites. kind of jumping into state of health or management and monitoring, certainly leveraging SNMP version 3 is a great place to implement from. With those MIBs that are being supplied from a number of RSU manufacturers, is a great implementation strategy to incorporate that into your management and state of health platform. Using DTLS to kind of add on a security layer for SNMP is definitely a recommendation in the long-term strategy. Certainly MIBs are maybe not always created equally and may wind up requiring fairly frequent refreshes, and a MIB from manufacturer A may not implement the same SNMP components or methods that manufacturer B implements. And so having that as part of that evaluation criteria in the procurement spec and any testing that you do before purchase is a good place to look at in terms of getting your best use out of implementation. So for a number of project deployments, we've implemented a cloud service, SNMP methodology. So at that point, you can add hosts to the implementation. There's some flexibility in terms around adding custom MIB support to that. This is very similar to the platform that we're leveraging for the Ann Arbor Connected Vehicle Test Environment. As you drill a little bit further down into the application suite, you can look at site-specific or corridor-specific devices. Each one of the application pieces that are key for that management and monitoring evaluation, and looking at when a failure occurs, how far into the application or the RSU do you need to take a look at to assess what's going on with it versus just sort of straight up knowing, hey, look, I've got a communications backhaul failure along corridor X. And so that helps to kind of quickly assess what's going on as you ramp up or scale up the number of RSUs that would be deployed within an infrastructure or for a client. When you look at drilling down sort of the next tier within the application set, you can take a look at the combination of application components that ultimately are successfully running, and that again helps kind of aid in that troubleshooting process to assess what's going on with the unit at that point in time. From an O&M recommendation standpoint, certainly the standards and knowing each one of the critical pieces is a recommendation. So from J2735 on the SAE side, knowing the IEEE 1609 2, 3, and 4 standards is a key element. Looking through if I'm going to take and bring in data from OBUs that are traversing my corridor and store them for the long term, what data elements out of part 1 and part 2 do I want to store, and do I want to implement that all in one chunk or break it up into sort of phased implementation, goes to the storage strategy and ultimately other application uses as that data set becomes richer and more deployment sites are implemented across an agency or a project area. And certainly, as Blaine was talking about early on, a number of early deployers have looked at and implemented onboard units for use in multiple fleet vehicles that may traverse a corridor. It helps kind of fill in data for that specific corridor. Also helps if you're trying to demonstrate and get sort of leveraged value out of that early implementation to your stakeholders or to your executive management, because nothing says like this is working when you can actually see it on a heads-up display inside of a vehicle and you're seeing that sort of dynamic data change in real time. It helps sort of solidify the implementation and the benefit of doing this as an agency. And certainly bench testing, interoperability testing between devices, while OmniAir is coming online with test laboratories and certification, testing, and Turner Fairbanks is working on their testing pieces as well. Certainly any new applications that are kind of coming through the market space, it's still kind of a good recommendation to evaluate those testing configurations and integration parameters that are specific to your agency prior to going out and doing field deployment. Getting a little bit into the backhaul communications piece, there's certainly opportunities to leverage what's out there in a number of locations. Being able to broadcast secure and encrypted messages, attaching to production certificates via the security credential management system is a key to maybe where we would like to go as a market or as an industry in the long term. The sooner we can start kind of implementing those for early deployment locations helps from a certification standpoint, from a validation standpoint, and as well as from a, I call it an IT professional standpoint of helping to secure the RSU as a new network device on the edge of an agency's network. So the more sort of security layers that I can add to the broadcast and the overall implementation helps from making this a more stable environment that is harder to penetrate or to hack through and become a bad actor for a deployment. And certainly, there's a role in that backhaul communications aside from the security aspect, but to get data back to a back office, and whether that's within a TMC or even out to the USDOT or like the operational data exchange or something to that aspect, sort of leveraging that CVRA implementation are opportunities to kind of leverage that with the backhaul communications, as well as supporting remote configuration and troubleshooting. So that way I don't have to physically be on site with the RSU and the cabinet door open, plugged into the network switch in order to figure out what's going on with it, or to change a configuration parameter or load a new message set for broadcast deployment. As a real quick kind of touch on security, there's certainly PSIDs that are being managed as part of the registration authority on the IEEE side. Those PSID numbers have an effect on how I advertise services that we were talking about in the early part of the presentation today, where like WSA might be for my agency on channel 172. Those PSIDs kind of combine with that to make sure that the OBU is also listening to the right channel and being able to respond correctly. And so that all kind of ties in with SCMS, the messages set that I ultimately deploy on, and how those PSID numbers are implemented for those specific sites and applications. So through the Camp LLC organization, they have a live wiki site. There will be some reference links towards the end part of my section of the presentation, as well as this site link, that help kind of lay out some of those breadcrumbs and kind of put the pieces together in terms of which applications and what message sets would be broadcast with which PSIDs, and those wind up needing to be kind of included with my procurement specification as I'm selecting devices or evaluating things. So there's definitely, I guess, really the first in production use of an SCMS provider we've been working with has been Green Hills. There are a number of network pieces that wind up needing to be put in place to allow the RSU to communicate with the SCMS. So implementing TLS on the network, allowing port 443 traffic in and out of the network through to the edge device is an important implementation piece for this to work. So far we have used IP6 native on a number of projects, and that has worked well. There's an IP4 element of this that can be deployed. We specifically haven't tested that on our end yet, but that may be other pilot locations that could speak to that much more in depth, perhaps. On the long term, it may be good to look at the commercial terms and service level agreement pieces for Green Hills if you're going to implement a number of RSUs at scale and tie them to production certificates. So that might be something to kind of recommend looking at with your legal staff to make sure that all of those pieces line up for your specific agency. Like a number of things, price, performance, and implementation requirements for new providers as they enter the market are likely to have variables or variances in how those affect integration and deployment. For a number of RSU deployment projects, we've implemented PSIDs by application from that IEEE registry, and this is just some of those PSIDs by application, so there's some breadcrumbs for folks if you're looking for what some other folks have used or implemented in the past. As a real quick data transfer example, so when I have a OBU deployed in a vehicle, I'm ultimately broadcasting SPaT and MAP from the RSU out to the vehicle itself. The BSM and probe vehicle data message would respond back and be able to pick up from the channel assignment on the WSA that's also broadcast from the RSU. If I have an RTCM or real-time correction message, that would be deployed and broadcasted from the RSU out to the vehicle itself. The signal controller would be sort of the master source of the raw SPaT message. It could, in a number of cases, directly output to the RSU without third-party hardware. In a number of cases, you could implement with the connected vehicle coprocessor or the V2I hub as a intermediary to forward SPaT to or send the SPaT message out to the RSU to ultimately broadcast that out. Where I'm implementing a backhaul communication, I would ultimately have an ISP connection that goes out to the internet and allows connection to SCMS to an off-site back office data analysis location, or if it's inside the network, that could be at the TMC off the back-end switch at that location. Certainly a firewall and packet inspection could be implemented at that sort of head-end location and implement security for within that sort of data transfer all through the DOT or the municipality network itself. So, how do we look at remote messages? So at some level, the configuration of WSA could be done through SNMP or through SSH to the RSU, and then that would ultimately be sent out to the OBUs or broadcasted out. The probe data message, in terms of configuring what the vehicle will respond with, if it's implemented with a probe vehicle data message, that again could be configured through the RSU itself or via SNMP remotely and broadcasted to OBUs. The signal phase and timing data would come from ultimately the traffic signal controller through to the RSU, be combined with the MAP broadcast, and both of those pieces broadcast out again to the OBUs themselves. The traveler information message would be a remote message, or could be a remote message load with that start and stop time that then gets broadcast within those parameters to the OBUs. In a number of cases, the OBUs are very, very remote. You may not be configuring those parameters kind of remotely. Most agencies would set those OBUs inside their fleet vehicles and update firmware from within a maintenance shop or some location like that. And once that firmware has been updated and tested, then at that point I would kind of push those across multiple fleet vehicles, and then when they're out traversing the roadway, get into a coverage area for an RSU. Now at that point, those BSM messages or signal request messages get sent back to the RSUs, and whether I have forwarding enabled, those RSUs would again send that message set on to a back office data aggregation point. There's several options. There's several folks that have developed configuration and monitoring tool sets in terms of being able to configure a message and send it to an RSU. The USDOT data warehouse tool, as it stands, will enable you to kind of create those map and TIM messages through that methodology. In the cases where you need a higher resolution LiDAR data set to get much richer positional accuracy for the map message, those pieces would be done offline via a toolkit, post-processed, and then the map file created and then deployed for the RSU in those locations. And then if you want to go through and testing and validation purposes, the camp verification document helps from that, what you would see in the in-vehicle device that's deployed and set up to make sure that those pieces are functioning properly at that higher resolution deployment aspect. So in a number of different backhaul scenarios, several folks or projects have implemented with shared use fiber. Some folks have implemented with a mix of fiber and wireless. And then in some deployment scenarios, they've been an all wireless scenario. So we'll just kind of real quickly touch on those pieces just to kind of show some folks what that may look like. So in Ann Arbor, it is a native IPv6 implementation on mostly agency fiber. There are separate VLANs that are structured within the network to protect, we'll call it inside traffic from connected vehicle traffic. So each one of the cabinet locations would have an RSU connected to a cabinet switch, and then ultimately the traffic signal controller would be connected to the same switch, and then those messages get sent to the RSU and broadcasted out. Connections to the SCMS and to your back office data aggregation is done through the city network out to a head end with a new firewall and router implementation and an ISP connection. So that way, from a bandwidth standpoint, there's no impact on, we'll call it the enterprise network for the city. And as we roll from 30 RSUs that are deployed within this configuration out to 80 RSUs, that bandwidth allocation or usage winds up being a critical driver to how this gets implemented at scale. The SCMS provider is a connection via the internet itself, so that's how those pieces are done. So each one of the RSUs are able to go through the city network out to the internet, reach to Green Hills via TLS, get a new certificate and pull that back and load it onto the RSU. Or if there's a scenario where there's an OBU that needs a top-off certificate, that request can be made through the RSU and kind of same topology path out to Green Hills to get that new production set of certificates loaded and topped off for an OBU. As an example of a wireline and wireless example, a number of folks have implemented ring networks and had RSUs at certain sites within the ring. So the network itself is redundant or resilient, and that provides a communication pathway to the RSU from a traffic management center. So if I've got data storage at that location, at that point I can send that through the network core out to the agency back office, where we've got wireless implementation out to, we'll call it remote nodes on the network. That still allows those RSUs that are deployed within those nodes or sites to communicate back with the network core. And so that's a different kind of strategy to implement or broaden out where I've got RSUs deployed within my network from a backhaul communication standpoint. One of the last examples we want to kind of talk through a little bit quickly is an all wireless scenario. A few folks have implemented with RSUs on cellular communications, and certainly that's an effect to the overall data plan itself as an agency and usage on a site-by-site basis. So you want to take a look at sort of that cost model for your wireless agreement or your carrier that you have access to from the agency side. Where we've got wireless Ethernet that could be deployed from a site-to-site standpoint through a corridor in place of fiber or copper wireline, that could be an implementation strategy to kind of again access a backhaul communication standpoint for the RSUs that would be deployed within each cabinet location. And then as those get backhauled up to, again, a back office location, those would then be accessible via the internet from an ISP connection through a firewall and a router into the TMC or a back office location. And whether I set up a test RSU at that site, that's again sort of an agency deployment choice at that point. If I want to equip a location that is closer to me from an early implementation or testing new applications as they bring those into my environment is an opportunity. And so with that, I'll kind of wrap up. These are some reference resource links to certain standards and documentation that's available to folks. And so with that, I will turn over and let Yingtao talk a little bit more detailed about the DSRC licensing component.
All right. Thank you, Brian. And good afternoon, everyone. My name is Yan Tao. I'm from the city of Madison, Wisconsin. I'm going to talk a little bit more about the DSRC licensing, using Madison's experience as an example. A little bit background information. So I have been leading a project at the city here, which is called the Smart City Initiative. And we're working with University of Wisconsin-Madison and a consortium of other public and private entities in the area to envision a next generation people and a data-centered transportation system for Madison. We developed a plan called Building a Smart Madison for Shared Prosperity. One of the projects that identified by the plan is the Smart Park Street Corridor project. It's our answer to the SPaT challenge, and it's Wisconsin's first connected vehicle infrastructure. It's a major corridor connecting downtown Madison and also UW-Madison campus with the only freeway that we have. It serves a lot of regional medical facilities, special events venues, schools, community centers, transit hubs, and fire stations. So it's a heavily used. It's also a heavily used transit corridor for some of our low-income residents living in the area. So we are pilot and deploy connected vehicle technology project to improve transporting safety, mobility, bus on-time performance, and also transporting equity. Together, we have 26 DSRC locations identified in the project, and so far we have 5 locations implemented. We are developing V2I, V2V, and V2X applications right now. We would like to establish Madison and Wisconsin as the upper Midwest hub for CV and AV. A little bit about the DSRC. It's part of the Intelligent Transportation System Radio Service Communication Frequency Band, normally referred to as 5.9 gigahertz band, as defined by Code of Federal Regulation 47, Parts 90 and 95, also by FCC Rules Part 90, Subpart M. One thing that people have to keep in mind is that this band is shared with some other users, such as some federal users authorized by the National Telecommunications and Information Administration, and also some commercial satellite operators. Luckily, these users are mostly in the remote areas of the country, but if you're working in a suburban environment or a rural environment, sometimes you have to deal with interference from these users. Before you deploy DSRC, agencies are required to know their responsibilities. You have to review the FCC service rules, regulations, and technical requirements. And you have to plan your deployment in a way that makes most sense. And there's a lot of licensing administration that's involved. And you have to coordinate with other users to reduce interference. And there's a lot of ongoing management commitment to it, such as to add new units, to delete the units that you no longer use, and also to coordinate with new users who are installing new equipment in your area. There are three main steps for the DSRC licensing. The first step is the FCC registration number. The second step is the non-exclusive geographic area license, which Raj and Brian kind of talked a little bit about and referred to as a blanket license. The third step is the individual roadside unit registration. We recommend you plan for 3 months to go through all the 3 steps. But definitely, the more time you have, the better chance you can make sure your project is on schedule. You have to go to the FCC's query system to get a registration number. It's also called the commission registration system. Basically, you go there to provide agency information and to get approval for login information. Once you have that, you can go ahead to move on to the second step. But it's a good idea to check whether someone within your agency may already have something called the radio frequency correlators. If they do, chances are that there's already a registration number around that you may be able to use. So actually, they'll maintain a list of radio frequency correlators, so that's a good reference. Also, FCC has a list of existing FR numbers and contacts. So for Madison, we kind of skip that process because we, as a type engineer agency, we maintain the city's 911 radio communication system, so we have been well involved in that already. So we have to skip that part. Second step is called the non-inclusive geographic area license, which is based on the public or the private entity's legal area of operations. And you have access to all channels in the 5.9 gigahertz band. It's typically granted for 10 years, and it may be renewed. For public entities, typically you apply under the IQ radio services. That's kind of the code for public safety ITS component. For private or commercial entities, you typically do that through the QQ radio service, which is a non-public component of it. The form needed is the FCC Form 601 and the Schedule D16. It can also be handled on the website, the Universal Licensing System online. The third step is the individual RSU registration. A separate application is required for each roadside unit, but you can do batch applications. You can do multiple sites with one application, but you have to provide information for each location, including make and model, serial number, antennas, latitude, longitude, height, what kind of support infrastructures that you have. The form to do that is the Form 601 and the Schedule M to register. And also, to certify construction, you need a Schedule K. Again, it can be handled by the online system. For that process, it takes about a month or so, but sometimes you get it sooner or later. Actually, I was wrong on that. So the geographic area license typically takes about a month. Actually, the individual registration for RSU, that's actually pretty quickly. Sometimes we heard that if you do electronically, you can get the same, you can get an answer within the same business day. So apologies for that. Also, some ongoing considerations for the SRC deployment. You have to file a notice of construction within a year after you got the registration. Otherwise, it will be placed on termination pending status. When that happens, a licensee has to file a petition for reconstruction in a timely manner. Otherwise, it may be terminated. Also, inactive license or site registration will be discontinued in a year. It's your responsibility to delete that record from the database. That's all I have. Some quick references. The first one is the Federal Highway Administration Connected Vehicle Environment Guide. The second one is the NACO DSRC Licensing Guide. That's a pretty short and sweet document that has a lot of good information. Thank you very much.
Thank you very much, Yang. So we are almost done with our time. The presentation took a little bit of time, but during the presentations, our panels here answered each of the questions that you had. I think everybody had access to those, so I hope your questions are answered. I'll just quickly ask the last question from Ray because he just put it in now, so to see if our panels have any answers for that. So the question is, if you have to register RSUs by serial number, what happens when maintenance has to replace it with a different unit? So Raj and Blaine had another commitment and had to leave the conference call, but from the people who are on, do you have any ideas about this question?
So this is Deb Curtis from USDOT. I'm not 100% sure about the FCC process, but I do know that they are looking at these large sort of agency-wide licenses that cover the jurisdiction of the owning agency. So, Ray, I'm not 100% sure, but I would think that, changes for maintenance and that sort of thing might very well be covered under you license the units and the serial numbers when you get them, and then where they're located can be something that can be amended later, or maybe it's just in particular covered under that license. But I'm not 100% sure. It's a good question. We'll take note of it and see if we can get you a more definitive answer back to you. Okay?
Thank you.
So Deb, just as a real quick follow-up, in our couple of experiences requesting licenses, we haven't had any issues in terms of updating or requiring to update for a serial number replacement. It's more on that kind of initial application side that they're looking for the position and sort of what the initial unit deployment was, or that seems to be the pattern so far, maybe is a better way to put it.
And I think that that's probably something that is going to end up being revised or sort of settle into a de facto way of doing things once we have more large-scale deployments underway and maintenance issues and changing and swapping out things becomes more of a commonplace sort of occurrence. But again, we'll take note of it and take it back to the people who are handling the FCC side of work here at USDOT and see if we can get a more definitive answer for you.
Thanks, Deb. Thanks, Brian. So I guess that would conclude the Q&A part. I'll leave this page open so you can directly download slides or register for future webinars if you need to. I just want to thank everyone, the participants, the presenters that we had here today that shared all this great information with us. Again, this webinar was recorded and that would be shared with you along with the presentation slide. Thank you very much and have a great rest of your day.